Hello, algebra. So today we are practicing adding and subtracting square roots again and then multiplying square roots as well. So just a reminder, when you're adding and subtracting numbers with square roots in them, as long as the square roots are all the same, you can just add the whole numbers and keep that same square root. It's almost like they're a variable, like 3x plus 7x equals 10x, right, where the x stays the same. So since all of these have the same square root of 5, we can just add their whole numbers. Add or subtract. 3 minus 2 is 1, plus 3 is 4, times the square root of 5. And so the first ones on your worksheet today are that simple as well. So what happens if your radicals are not the same, your square roots are not the same? Well, what we're going to do is we're going to break down our square roots, and they should end up being the same. Notice 54 breaks down to this. We've got a pair of 3's that we can pull out and multiply times that 8, so we get 24. And then what's left are these, right? 24 times the square root of 6. Now notice that matches my second one now. Okay, now I can subtract them. 24 minus 4 gives me 20 times the square root of 6. Okay, one more like that. This one doesn't have any whole numbers, but we do have square roots that we can break down, right? 28 can be broken down into 7 and 4, 2 and 2, right? So that gives us a pair of 2's that we can pull outside the square root box. And that leaves us with a 7 on the inside. Okay, square root of 63 is 9 and 7, 3 and 3. So again, we can pull these 3's out, right? Put them outside. That leaves the 7 in here. And now we can add them up together. So now we get 5 times the square root of 7. So if they don't have matching square roots or radicals, break down the radicals, pull out the numbers that you can, and multiply them times the whole numbers. And when you're done with that, you should end up with 2 that you can combine. How about when you're multiplying radicals? When you're multiplying radicals, you can just multiply the numbers under the square root box times each other. So we're going to do some distributive property here and take this first number times both of those inside numbers. So I get the square root of 50 minus the square root of 15. Now, one thing to remember today is if you can break down any of your square roots, you should always do that. So here would be a good example of that. Don't leave anything like the square root of 50 that you can break down. Notice I can break this one down a little bit because I do have a pair of 5's that I can pull out, and I end up with that, right? Square root of 15 doesn't break down any farther because it just breaks down to 3 times 5, so there's nothing I can pull out of my square root radical box. So there's my final answer. That's as low as I can go. I can't combine those or anything because they don't have the similar square roots. So that would be how you would finish up that one. Let's do one more where we're multiplying radicals together. This one's got some whole numbers. And notice this one's got 2 pieces. They're both binomials. So we're going to have to solve these using the FOIL method, right? First, outside, inside, last. Don't forget about that method. This is very much like 21 and 23 on your work today. So let's multiply the first pieces together. So this piece times this piece. Okay, 4 times nothing, as far as my whole numbers go, gives me just 4. Then my square root of 6 times my square root of 3 gives me this, right? Okay. Now let's do the outside numbers. So I've got this and this. So I'm going to get minus the square root of 60. My inside numbers, I have 2 whole numbers times each other this time. So I get 16, so plus 16, times the square root of 15. And now my lasts. So my last 2 numbers, here they are. Okay, notice I have a positive times a negative, so it's going to be a negative 4, just a whole number 4 times nothing, times the square root of 50. Notice a lot of these have square roots that you can break down a little bit. For instance, this first one can be broken down a little bit. Notice we can pull out a pair of 3's and take that times the original 4. So I get 12 times the square root of 2. This second one, negative 60, we can break down a bit. 6 and 10, right? 2 and 3, 5 and 2. Notice we can pull out a pair of 2's. Okay, so we're going to put that out in front. And then square root of 15 on the inside. This third pair, can't do anything with because I can't break down 15 any farther. But this last one, I can definitely do some things with. So let's break down this 50 a little bit. 5 and 10, 2 and 5. Notice I got a pair of 5's that can be broken out and taken times this negative 4. So I get negative 20 times the square root of 2. So notice now here at the end, we've got a few pieces that we can combine. We have this piece and this piece that would combine well. And we have these two pieces that would combine well. Okay, so 12 times the square root of 2 minus 20 times the square root of 2 would give me negative 8 times the square root of 2. And then if I combine these two middle pieces, negative 2 and positive 16 would give me positive 14 times the square root of 15. So that's your final answer. All right, let's do a few right out of your work. Notice these first ones are some of the easy ones. We'll do number 3. Notice all of these have the same square roots. All right, they all have 5. So we can just add and subtract the whole number. 6 minus 2 is 4. 4 plus 8 is 12. So that one's one of those simple ones where you can just do that and have your final answer. Let's do number 9. Number 9 does not have matching square roots or radicals, so we're going to have to make them match by breaking them down a little bit. Can't break down this first one at all. It's as low as it can go, but this one we can. 12 breaks down to 2 and 6, or in other words, 2 times 3 times 2. So notice we got a pair of 2's that we can pull out and multiply times this 2 that's out here already, so it becomes 4 times the square root of 3. So notice I'm doing 4 times the square root of 3, right, this first one, plus 4 times the square root of 3. Or in other words, 8 times the square root of 3. Here's an example of a multiplying one. We'll do number 19 together. Notice I'm going to do this outside one times both of our inside pieces. Okay, so let's do that. The first pair would just be 3 as a whole number times nothing, square root of 12, right? And then minus, because it's a minus part, negative 2 times nothing, so just negative 2 times the square root of 18. Notice I can't combine them yet, but I can break down their square roots. Let's do that. 12 becomes 2 times 2 times 3, right? And 18 becomes 2 times 3 times 3. So notice in this one I can pull out a pair of 2's, which I'll multiply times my 3, so I get 6 times the square root of 12, right? Minus, now this one I can pull out a pair of 3's, which I can multiply times my whole number, 6 times the square root of 2. And that's all the farther we can go on that one. So we'll circle that as our final answer. Let's look at number 23 together. Here's a FOIL method one. Notice we have two binomials. So we're going to have to take the firsts, the outsides, the insides, and the last. So let's do this one right now. Here's our firsts. Square root of 8 times the square root of 5 gives us the square root of 40. Now the outsides. Here's our outsides. We'll take those times each other. Square root of 8 times the square root of 3 gives us the square root of 24. The insides, so these two, square root of 2 times the square root of 10 gives me the square root of, times the square root of 5 gives me the square root of 10. Okay, and now the lasts. Square root of 2 times the square root of 3 gives me plus the square root of 6. Okay, a lot of these square roots we can definitely break down. So we can see if we can combine any, right? So I can break this one down, for instance, to this. Notice I can pull out a pair of 2's. So 2 times the square root of 10, that one breaks down to. This one, 8 and 3, in other words, 2 times 2 times 2 times 3, right, is what that one breaks down into. Notice once again I can pull out a pair of 2's, but then I have a square root of 6 left over. 10 I can't break down anymore. That's as low as it's going to go. Okay. This one I can't break down anymore either. But notice when we get to that step, we can definitely combine some pieces, right? I got a square root of 10 piece and a square root of 10 piece. So think of this as like 1 times the square root of 10, right? So I get 3 times the square root of 10, and I can combine my two square root of 6 pieces, plus 3 times the square root of 6. And that's your final answer. Hopefully that makes some sense and reminds you of how to do all these different types of problems after we had a little bit of an Easter break. But don't be afraid to contact me and let me know if I can talk you through any types of problems as you go. Have a good day, guys.